Welcome to the Pre-Calculus Mathematics for Calculus textbook series. This lesson is written based on Chapter 1, Section 6C, Square Roots of Negative Numbers. So today's lesson, you're going to learn how to perform operations with square roots of negative numbers. Before you start, make sure that you know how to simplify radical expressions. You're also going to learn the following new word, principal square root. Let's get started. For our warm-up, pause the video and simplify the expressions below. I'm going to show the answers in 3, 2, 1, now. Okay, if you struggled with this, go back and review Chapter 1, Section 2. Now let's learn about the square roots of negative numbers. Okay, so suppose that we simplify the expression 2i squared. This is 4i squared, which equals 4 times negative 1, and our final answer is negative 4. Now, since 2i squared equals negative 4, the square root of negative 4 is 2i. We can say the same thing for the square root of negative 9, 3i, negative 16, 4i, and so on and so forth until we get to the square root of negative r, which is going to be I times the square root of r. Now, numbers of this form with only an imaginary part are called pure imaginary numbers, and these can be used to simplify square roots. Let's formalize. For every positive real number, you have two square roots, positive square root of r, negative square root of r. Now, for negative numbers, it's the same idea. Every negative number also has two square roots. The square root of negative r is positive and negative I root r. Formalizing this, if negative r is negative, I know that sounds repetitive, but it's important, then the principal square root of negative r is the square root of negative r, which is I times the square root. So we have two, I root r and negative root r. Let's take another look at the product property and the quotient property. The product property is the square root of a times b equals the square root of a times the square root of b. The quotient property tells us that the square root of a divided by b is the same as the square root of a divided by the square root of b. We have to be careful with this, okay? If you have two numbers underneath your radicals that are negative, for example, the square root of negative 2 times the square root of negative 3, we have a problem. We can't apply this rule. It's tempting to make that square root of 6, but it's wrong. What we should do is simplify each square root and then multiply our answer. So square root of 2 times the square root of 3 is actually I square root of 2 times I square root of 3, which is I square root of 6, which is negative square root of 6. We need to evaluate the following expression and then express the result in complex number form, a plus bi. My first step is to simplify the radicals. So it can be very tempting to do the foiling first, but I'm telling you, simplify the radicals and then apply your properties. First, square root of 12 becomes 2 root 3. Square root of negative 3 becomes I root 3. Square root of negative 4 becomes 2i. Now I can FOIL. And I get this lovely expression, which just needs to be simplified a bit. That I squared is a negative 1, and I get 6 root 3 plus 4i root 3 minus 3i root 3 plus 2 root 3. Now remember, we're going to keep our real terms together and our imaginary terms together to get a root 3 plus I root 3. Congratulations! You know a lot about the square roots of negative numbers. Now, before you go, let's tackle a true-false statement. The product rule for radicals applies to real numbers only. Turn to your classmate and discuss, and I will see you in the final part of the four video series.